Welcome to The Explainer. Today, we're unpacking one of the absolutely most profound biological paradoxes of the human body, our sleeping minds. Think about it. Every single night you close your eyes, your body completely powers down. But your brain? Your brain lights up like a pinball machine. Without any external input whatsoever, you experience these incredibly vivid images, intense emotions, and highly complex narratives. It's a massive, fascinating neuromystery. And today, we're going to decode the actual biology behind it. Okay, let's dive right into this. Why exactly does your brain go to all the trouble of generating these bizarre, hallucinated virtual realities every single time you go to sleep? Well, to figure that out, we have to look at the biological mechanics of sleep, not just as some passive rest state, but as a complex set of clues. By examining exactly how our neurons fire, how different brain regions communicate, and how our bodies literally paralyze themselves, we can actually solve this ultimate mystery of what a dream really is and why it is so biologically essential for our survival. Think of your brain like an incredibly advanced computer. In your normal waking state, this computer is constantly bombarded with inputs from the outside world, right? Your eyes, your ears, your sense of touch. You've got high-level motor coordination to navigate reality. But during REM sleep, rapid eye movement sleep, the brain essentially just unplugs its external input sensors. It completely stops listening to the outside world. Instead, it boots up an intense, entirely internal virtual reality simulation. The sensations you feel during a dream are undeniably vivid, but they are completely self-generated by the brain's internal circuitry. And this brings us to a really fascinating state of mind called primary consciousness. Simply put, this is the basic awareness of perception and emotion. When you're awake, you have secondary consciousness, or metacognition. Basically, you are aware that you are aware. But in a dream, you lose that secondary layer. You experience this primary consciousness, getting completely trapped in a single-minded scenario. Your brain doesn't actually realize it's detached from the real world. You totally accept the bizarre logic of the dream because the critical, self-reflective part of your brain is temporarily offline. Now, what's really interesting about this is how we actually discovered where this dream state comes from. For the longest time, we just assumed dreams must come from the highly evolved, advanced part of our brain, the forebrain. But early transection studies, which were famously done on cats, proved otherwise. When scientists actually separated the forebrain from the lower brainstem, the results were wild. The isolated forebrain showed almost no signs of REM sleep, but the primitive brainstem, it kept right on generating the electrical signals of REM sleep perfectly. This proved that the trigger for our most vivid, complex dreams originate deep in the most primitive, ancient part of our brain. So what are those exact trigger mechanisms firing off in that primitive brainstem? They are known as PGO waves. That stands for pons, geniculate, and occipital. Basically, these are massive electrical spikes that start in the pons, travel through the geniculate nucleus in your thalamus, and finally hit the occipital cortex, which is your brain's primary visual processing center. It's such a stunning contrast, really. These PGO waves are cold, predictable, strictly mechanical biological signals, and yet they are the exact sparks that ignite the deeply personal, intensely emotional, and vividly bizarre imagery of your dreams. This primitive origin raises a massive question, though. If dreams come from this ancient brainstem we share with so many creatures, does every animal on Earth experience these bizarre simulations? Well, by turning to the animal kingdom, we find a sort of evolutionary mirror. Looking at how different species sleep gives us some incredible clues about why this biologically expensive and, honestly, highly vulnerable state of dreaming evolved in the first place. Comparing REM sleep across different species is absolutely revealing. The amount of REM sleep a species gets correlates really strongly with how immature and helpless they are at birth. Take the platypus. Born completely defenseless, it gets an enormous amount of REM sleep. Humans, born with intermediate maturity, we get a moderate amount. But the dolphin? Dolphins are born highly mature. They literally have to immediately swim to survive. They get almost zero REM sleep, maybe 15 minutes a day, and they even sleep with only one half of their brain at a time. It shows us that REM sleep is intrinsically tied to early brain development. Just to emphasize that point, though, 8 hours. A platypus gets a staggering 8 hours of REM sleep every single day. That is more than any other animal on the planet. They exhibit this dramatic, twitching motor activity almost continuously throughout their sleep. So, the next time you're at a cocktail party, you can casually mention that the bizarre, egg-laying, venomous platypus is also the undisputed heavyweight champion of dreaming. So the crucial point is, if a platypus is twitching away and our own brains are firing on all cylinders, sending out these massive motor commands to run, jump, and fight during our dreams, why are we safely tucked in bed? Why don't we all just get up and literally act out the intense virtual realities our brains are running? The answer is muscle attonia. This is the active biological suppression of your muscle tone. When you drop into REM sleep, a very specific region in your brainstem called the pontine inhibitory area basically flips a switch. It sends signals down to your medulla and your spinal cord to actively hyperpolarize your motor neurons. So your brain paralyzes your body so your mind can safely run wild. If you've ever woken up and felt entirely unable to move for a few terrifying seconds, you've experienced sleep paralysis. That's simply this attonia mechanism lingering just a split second too long after your waking consciousness has come back online.
And this brilliantly illustrates exactly what happens when that vital safety switch gets broken. In normal REM sleep, if you measure muscle activity, you get a completely flat line, total paralysis. But if a tiny, precise lesion occurs in the subcoriolis region of the pons, that paralysis mechanism just vanishes. The muscle activity goes wild. In animal studies where this happens, they enter REM sleep, but without atonia. They physically stand up, walk around, and aggressively attack imaginary objects that only exist inside their dreams. Now, this isn't just some abstract animal experiment. It happens to humans too. It's a clinical condition known as REM sleep behavior disorder, or RBD. People with RBD literally act out their dreams, which, as you can imagine, can be incredibly dangerous to themselves and whoever is sleeping next to them. Interestingly, scientists found that RBD is highly linked to degenerative changes in the ventral midbrain, and it often progresses to Parkinson's disease later in life. It's perfect proof that dreaming is a highly active motor state that requires a heavy biological brake pedal to keep us still. All of these biological clues, the primitive brainstem origins, the electrical PGO waves, the muscle atonia, they all came together for a massive breakthrough back in 1977. Harvard psychiatrists Alan Hobson and Robert McCarley proposed a radically new way of looking at dreams, officially framing the brain as a dream state generator. They essentially took dreaming out of the realm of pure psychology and mysticism, and they grounded it firmly for the first time in hard neurobiology. They called it the activation synthesis hypothesis, and here's how it works. During REM sleep, your brain gets highly activated by those primitive signals shooting up from the brainstem. But remember, the external inputs are shut off, so your brain's cortex is being bombarded by all this random, intense electrical activity, and it desperately tries to make sense of it all. It attempts to synthesize a logical story out of pure chaos. So if a random firing happens to stimulate your vestibular system, your brain synthesizes a dream that you're flying or falling. The dream is literally just your brain's best attempt to stitch random biological activation into a coherent narrative. Let's move forward, though, and see how this builds. Because as brain imaging technology evolved, think fMRI and advanced EEG, we realized this wasn't just a simple on and off switch. Our understanding grew way beyond that. We now know the brain is actually taking a highly dynamic journey through a complex three-dimensional space every single day. This modern understanding led to the AIM model, which is essentially a three-dimensional map of consciousness. It rests on three main pillars. Number one is activation. Just how active is the brain overall? Number two is input-output gating. Are the gates to the outside world open, or are they locked shut? And number three is modulation. What is the chemical balance of the brain, specifically the shift between different neurotransmitters? When we take that AIM model and apply it to REM sleep, everything just clicks into place. In a dream, activation is high. Your brain is burning just as much energy as when you're wide awake. But input-output gating is low. The gates are locked tight. You can't feel the bed sheets, and you can't move your legs. Finally, modulation is low. There's a massive chemical shift where aminergic chemicals, like serotonin, drop to near zero, while cholinergic chemicals spike. This highly specific chemical cocktail in a locked, highly active brain, that is the perfect biological recipe for a dream. Which brings us to the ultimate synthesis of why we dream: proto-consciousness. This theory suggests that dreaming is actually a primitive, virtual reality generator built right into our biology. Especially early in childhood, your brain uses REM sleep to create a proto-self, an imaginary you moving through simulated environments. Your brain is essentially running offline test simulations to build the foundational architecture of your waking consciousness, preparing you to anticipate and navigate the real world before you even fully experience it. So what does this all mean for you right now? It means that your waking life, your ability to problem solve, navigate high-order social situations, and frankly remain sane, is entirely dependent on your dreaming life. Dreaming isn't just some random noise you can ignore. It is an optimal, highly necessary preparation state. It facilitates dynamic learning and crucial neurological maintenance. Without that offline simulation, your waking software simply starts to crash.
As we wrap up this explainer, I want to leave you with a pretty provocative thought. Tonight, when you drift off, and that muscle atonia kicks in, and those PGO waves start firing through your visual cortex, what is your own proto-consciousness building for you? What complex biological engineering is happening inside your head to prepare you for tomorrow? It is a virtual reality simulation far more advanced than any computer on Earth, and it happens every single night right behind your closed eyes.
Thank you so much for joining me on this deep dive. Hey, if you want to keep your body as finely tuned as your sleeping brain, be sure to check out Dr. Gandadhar Physiotherapy and Rehabilitation Center at Amir Pet. Give them a call at +91 8686 105177. If you enjoyed this explainer, please hit that like button, share it, and subscribe. And don't forget to press the bell icon for more. Visit our clinic for any physical therapy and pain relief treatments. See you next time.